Well, there's two main drivers for the cloud evolution. I mean, the cloud's been around for a while, but really it's all about the data that's in the cloud and how it's being processed. So today we have two drivers. One of them is AI, and AI consumes a lot of data. And so there's a huge emphasis on building out data centers where you can process all this data using AI technologies. And of course, that drives the build out of data centers, and there's a lot of focus on that. The other thing is, this data is really, really important. It can be personal data, it can be financial data, it can be highly confidential stuff. And so there's a concern about the security of this data. And so while it might be the thing to put your data in a public cloud, everyone's starting to think about, how do I actually put some of that data more locally because it's accessible and it's better protected? And so there's even the whole concept of sovereignty, making sure that the data stays within a country or a region. There's also questions about whether or not this data is secure. So there's boundaries and firewalls and security aspects to where the data is. And this is also driving a lot of data center construction. Well, the hot topics around data centers today are location, compute, the energy that it takes to run these data centers, the cooling, these kinds of aspects. People don't talk a lot about networking. It's a silent sort of plumbing that happens inside. But actually, I mean, things like location are super important, because you got to find a place where you can get enough power to the data center. Often you need a source of liquid like water to help in the cooling of these environments. Of course, people talk about GPUs, and there's a lot of action along the GPUs that NVIDIA and AMD and Google and others are developing, because these are, of course, the engines that drive AI computing. And of course, the other things that go into a data center, like storage. Where do you put your data? You obviously have to have storage. It has to be close enough. It has to be huge in capacity and easy to access at very low latencies. So there's a ton of things that go into a data center. But then you talk about the energy, and the energy that these data centers are using can be massive. We used to talk about racks having 20 to 30 kilowatts. Now we're looking at 600 kilowatts type racks, because the GPUs are consuming so much power, and you can pack a lot of them into a GPU server. And so the power requirements per rack are going pretty crazy at this point. And then when you consume that much power, it generates a lot of heat. So there's all sorts of new technologies of how do I dissipate this heat. And we've gone from air-cooled systems to liquid-cooled to maybe even immersion in liquids. So all sorts of new technologies to handle the challenges of these new architectures that require so much intensive compute. There's a lot of networking that goes into a data center. That networking can be behind the scenes, connecting GPUs together and connecting GPUs to storage. We call that the back-end networking of a data center. There's the front-end networking. How do the applications that want to talk and use the GPU capabilities, how do they get their information, their requests to the data center? So there's the front-end networking. And of course, there's networking beyond what's inside the data center to how the data centers actually connect to each other and to the enterprises and consumers of these data centers. And there's obviously a lot of somewhat conventional networking that goes into this wide area connectivity. But there's also some very specific capabilities that we want to introduce as we connect data centers together, because sometimes, because of the power requirements of these data centers, you actually can't put all your capabilities into one data center. You don't have enough power or cooling in a particular location. So you want to, network a number of data centers together in order to sort of create this large virtual supercomputer that allows you to, do massive computations. Then you need some very specialized networking that has low latency, is pretty much lossless in order for you to be able to connect all these data centers together and make them look like a single unit. And so that's kind of the arena where we're involved in trying to get the connectivity together between these data centers and within the data center. Okay, so the cloud now is this collection of data centers, and that's where you can think of them as modern-day factories, and that's where things happen with the data. So you can consider that these data centers are actually the organs of a body that are performing various functions, whether they're storage functions, they're compute functions, they're inference functions, they're learning functions, and so on. And there has to be something that allows the organs to talk to each other, and that's kind of where networking comes in. It's the veins and the arteries, the nervous system that connects all of the various organs together in this body that we call the cloud.